Right, I'm absolutely delighted now to be joined by Nergis Mavalvala. Welcome.
Thank you very much, Stephen.
Thank you very much indeed for taking the time to talk to us today.
My pleasure to do so.
Now you won a big award here this week, didn't you?
Apparently, yes. I shared it with two other very clever colleagues, though, and which is also an honor to be, honored along with them.
Tell me a bit about the award and why you won it with your colleagues.
The award was for some work we have done together on something called generating squeezed states of light and on optical springs. And so squeezed states of light are an unusual quantum state that one can make light in. And it has a very special property that if you use squeezed states of light in clever ways when you make optical measurements, you can make optical measurements that have an improved signal-to-noise ratio. Now, improved compared to what? Well, the limit to how well you can do with a measurement with light, it comes from actually the Heisenberg uncertainty principle, because light, it comes in photons, it's quantized. And what we do when we make squeezed states of light is we actually manipulate the Heisenberg uncertainty principle so that for certain measurements, we can do better than the Heisenberg uncertainty principle, but in complementary measurements we would do much worse. So Heisenberg's principle is maintained, but we can manipulate it to do better.
And what are some of the applications of your work?
So the primary application that we have done this work for is for detection of gravitational waves. So gravitational wave detectors are they're large instruments, they're kilometers long, but they have a fairly simple measurement principle, and the measurement principle is that when a gravitational wave comes by, it stretches or shrinks the space-time distance between objects. So the space-time distance between you, Stephen, and me is continuously being stretched and shrunk by a passing gravitational wave. And now if I could shine a laser beam at you, and if you could reflect it back to me, and I had a really good clock, I could just measure how long the light took to reflect off of you and come back to me, and by looking at the variations in that light travel time, I could tell if a gravitational wave came by. And so that's the principle. And the squeeze state is of course then very important for us, because when we make this measurement without using a squeeze state, we get limited by the Heisenberg uncertainty limit. And then using the squeeze state, we've been able to do a little bit better. So that's one big piece of the award.
It sounds really, really fascinating. Now, there are a lot of people here this week. Obviously, March meeting does that. One of the things we've been talking about is diversity and the importance of young people in physics. Now, I know you believe passionately about that too.
Right, I do, and it comes certainly it comes from a sense of fairness, but it comes even more so from this idea that many people share, that excellence in everything we do comes in many shapes, forms, sizes, colors. And so if you really want to do something very, very well, you had better involve every shape and form that it comes in. And so diversity for me is not just about the principle of fairness. It's really about doing the best work you can with the best people that are out there thinking about the same things you are and having the same capabilities that would make this work go forward. So it's just part and parcel for me of doing good science. And
one of the other points that you made earlier is that it's important that people enjoy physics. It's not just about being able to do great work, it's enjoy it. And do you think physics is a career for a young person who could come in and really enjoy?
I think it's not just is a career, it's necessary that you enjoy it, because many parts of a career in physics are quite challenging. So if you don't wake up every morning sort of really struck by the conundrums that physics presents, and whether it's a minor experimental challenge or one of the major puzzle in how the universe is put together, I think you would be very unhappy. So I think enjoying it is absolutely necessary, more necessary than being good at it, actually, in my opinion.
Well, Nergis, thank you ever so much indeed for talking to us today. It's really fascinating, and well done again with the prize.
Thank you very much, Stephen. It's been a pleasure.